Hello again, everybody. There's video 4, chapter 1, section 9, patterns, equations, and graphs. And let me kind of give you an overview here. What they're going to do in this section is just, they're wanting you to kind of see the overall picture of the relationship between these three things. We get into a lot more detail as far as the equation graph relationships later. So this is kind of just a overall picture. We're going to spend a couple days on it to make sure you can make a table, make a graph, and go back and forth between them. But more detail to come later. So let's just get moving right into things here. Hopefully you're at home taking notes. From this, number 1 says draw a line from each pair of numbers in column A to its description in column B. And the words here, let's just go to this part on the right. The opposites, additive inverses, that's basically if you have two numbers that are opposites. In other words, they add to 0. That goes to only this one right here. And then the other word that you'll need to know, a really important word for us, is reciprocal. And examples of reciprocals are given in those two. You can draw the lines on your notes there and there. The true definition of reciprocal, this is actually somewhat important for us later, is if you multiply two numbers together, that's a some number times some number equals 1. That's the real definition of a reciprocal right there. Like if you took 3/4 times 4/3 and you multiplied that together, you get 12 over 12, which is 1. Same thing with those two right there. Negative times a negative is positive. Multiplicative inverse, which I will call it reciprocal, multiplies to equal 1. Moving on down here into inductive reasoning. Simply put, inductive reasoning is basically making a conclusion on a pattern that you observe. And we are going to look at that in some tables today. You probably do that instinctively, but what they call that is inductive reasoning. Let's slide on down the page here and look at some vocabulary here. I actually do like these. They have some words right here. Add, inductive reasoning, multiply, pattern, subtract. And based on this table, they're asking you to fill in the blank. Number 2 says to find the value of item 5. This one, I'm doing this question right here. It says you can look for a what? A pattern. A pattern goes in that blank right there. You look for a pattern. Look, 1, 4, 9, 16. You probably could figure out that next number. To obtain the value for an item, you can blank the item number by itself. All right, and so what they're saying here is if you notice that 2 times 2 gave me 4, 3 times 3 gave me 9, 4 times 4 gave me 16, you figured out, hopefully, that you could multiply 5 times 5 to get that last box right there. And how did you do that? You used inductive reasoning because you based it on this pattern that you saw in the table. So there's a fast example of what it is that they are having you look at here in chapter 1, section 9. Let's move on to page 2. Let's don't dilly-dally around. Hit pause as needed for you. Page 2. Identify solutions of a two-variable equation. Is the ordered pair 520 a solution for this equation? Now this is actually from the previous table, I believe. No, it's not. It's not. The previous table was number times itself. So it's saying, is 520 a solution to this equation, y equals 4x? So here's what you're thinking. This box right here. In 520, I need to identify the x and the y coordinates. Okay, x coordinate is 5. Remember that first number is x? The y coordinate is 20. That second number is 20. So for this equation, y equals 4x, you're thinking, well, now I can substitute 5 for the x and y for the, 20 for the y. And they show you that right there. Please fill in those blanks. Here we just put that y is 20. 20 equals 4 times x. We want to know if that's true by simplifying. Well, 20 is 20 and that 20 is 20, and as far as I know, those two things are equal. So guess what? You have a true equation, or you have a solution. Yes, 520 is a solution to the equation y equals 4x. Now let's move on down looking at using a table, an equation, and a graph together. Here we have a couple people running on the track. Will runs 6 laps. That's actually something I might want to be aware of. Will runs 6 before Megan joins him. And then they run together at the same pace. How can you represent the relationship between the number of laps that Will runs and the number of laps that Megan runs? How can you do that in different ways? And what we're going to do here is follow these instructions. We are going to use a table, an equation, and a graph to represent that situation. Let's begin with the table. All right, well, let's start with the number of laps that Megan runs. That'd be kind of like X, okay? Number of laps that Megan runs. Well, she could have run 0. I mean, she hasn't started yet. She could have run 1, 2, 3, just number up to 7 in the top row. And then on the bottom row, what you're going to do is, I'm going to hide this just a little bit from you. There, you should be able to see that still. The number of laps that Will runs, well, if he starts out at 6 before Megan has run, so then Megan joins him. He's already run 6, so when Megan runs 1, he's got lap number 7. And remember, they run together after he runs 6. So at lap 2 for Megan, he runs 8. And at lap 3, he has run 9, and on and on. And you can see that pattern, how that goes up. Will just starts at 6 and progresses up 1 at a time as Megan goes 1 at a time after that. So that table represents this situation. Again, like I said at the beginning, we're just looking at the ways that a table and an equation and a graph can be used interchangeably, because there are times when each of those might be valuable for us to use. So number 8 says circle the relationship represented in the table. Well, did Will run 13 more laps? No. Did Megan run 6 times? No. Did Will run 7 more? No. Obviously, that's the one we want right there. Will runs 6 more laps than Megan. All right, so knowing that, let's let X represent the number of laps that Megan runs, just like we did up here. If that is X, well then Y, which would be Will, okay, and they actually have it written right there. Y would be the number of laps that that Will runs there. So I can erase that one. Didn't really need that on my paper. All right, so if X is the number of laps that Megan runs and Y is the number of laps that Will runs, in this relationship right here is where I am. Y will always be, and here's what you've got underlined or circled. Y is always going to be greater than, because he had a head start. Unless Megan speeds up and outruns him, but that's not what happened according to our instructions. It says now you can write an equation to represent the relationship, and there it is. Y is equal to X plus 6. In other words, Will, which is Y, is equal to Megan plus 6. So there you have a table and an equation to represent that situation. So now we're going to go one step further and turn that into a graph on your next page. And here we go. Number 12, the ordered pair that corresponds to Megan running the trap, it starts at 0, 6. Okay, and then number 13 says use the table in exercise 7, which is your previous page. Write 3 more ordered pairs, and they gave you some to fill in here, and you can fill in those points. At 2 laps for Megan, Will ran 8, 4, and 10, 6, and 12. All right, so let's take a look at the graph. Okay, and you don't have to worry about writing this down for now. This is what I'm really concerned with here. All right, what you do want is you want to label your axis. Right there, I'm highlighting. This y-axis, that's going to represent the number of laps that Will runs. While this axis represents the number of laps that Megan runs here. Now you can already see the points plotted on there, but I'll talk you through it real quick. 0, 6 was the first point that you should have plotted. Remember how to plot those points? 0, first number X, he didn't go left, right? But he did go up 6. That's 0, 6 right there from this value. This value right here, 2, 8, would go over, well, that's 4. Doesn't it make sense that 2 would go about halfway between 0 and 4? Does to me. So I'm going to call that 2, 8. Right there. And the next one, 4, 10. Boom, boom. And the last one, 6, would be halfway between 4 and 8, I think. I'd put it there, 6, 12. And notice the nice line that those make. Go ahead and connect that line because this is what we call continuous data. In other words, he might have run 2.5 laps, anywhere in between. He's always run 6 more than Megan. And that wraps up number 14. I am at 10 minutes. I'm going to stop this. That's part 1 video, and we'll pick it up with part 2 here shortly.